Hi, everybody. Today we're going to analyze a triangle, and you'll notice that I have a triangle graphed here. I have the points plotted, A, B, and C, and I've labeled them on my diagram, and that's your first step. The next step is going to be, I'm going to go ahead and look at the slope from A to B. And of course, there's two ways to do that. One way to find the slope of AB is to use the formula for the slope formula. Everybody should already know it, and I probably shouldn't have to write it, but I'm going to write it out one time. The slope of AB, we are going to take y2 minus y1 over x2 minus x1. Now it's important that you know your subtractions. I'm going to take this y2, which is my second y. This is my first y, so I'm going to subtract them. 6 minus, notice that's a negative 2. That double negative is really 6 plus 2. Over. Now I'm going to subtract my x's. I have to do it in the correct order. That means that because I started with this one, I now have to start with this x. This is negative 2 minus negative 6. You have to be able to add these correctly. This is 6 plus 2. That double negative means the same as a negative times a negative. This means 6 plus 2, which is 8. And this means negative 2 plus 6. There's a double negative here. Negative 2 plus 6 is 4. Now, some of you realize that you could reduce this slope, but what I'm going to do is I'm also going to count it. We always start on the left and go to the right. So I'm going to count in red from A to B. That means to go from A to B, I am going to count up how far and over how far, because we talk about the slope being rise over run. So count how far up and over you need to go to do this problem. You should be following along on your graph. You should be drawing the 3 points on your graph. You should be counting it so that you can do this Edpuzzle appropriately. So the AB, the slope of AB, if I count it, it's going to be up 1, 2, 3, 4, 5, 6, 7. Try again. 1, 2, 3, 4, 5, 6, 7, 8. That is up 8 over 1, 2, 3, 4. Up 8, that's a positive 8, isn't it? Over 4. And there they are. Now what we can do is we could reduce this reduce this slope. But what we're going to do instead is we're going to use these two distances, this distance of 8 and this distance, I'm going to color code it, this distance of 4 in this right triangle to find the distance from A to B. Now there's two ways to find the distance. The easy way to find the distance is to take your note card, mark it from A to B. This is the easy way. We mark from A to B, and then we just simply count how far apart A and B are in terms of these squares. You can start anywhere. I'm going to go ahead and start here this time, a little bit different. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8, and it's between 8 and 9 units. So I'm going to say about 8.5. That means that my estimate for AB is going to be approximately 8.5 units. Now that's only an approximation. Now the distance AB we can find by looking at the Pythagorean Theorem. We know that A squared plus B squared is equal to C squared. So our distance formula we can use, I'm going to use AB, which asks for the distance from A to B, is equal to the square root of a squared plus b squared. 8 squared plus 4 squared. And we are going to square these two values. Notice the 8 comes from how far up I went. The 4 came from how far over I went. This right triangle has a hypotenuse AB. There it is. I'm going to simplify this. 8 squared is 8 times 8, which is 64. 4 squared is 4 times 4, which is 16. And when you add these together, you get 80. This is almost exactly 9. And the reason I know that is because you have to realize that the square root of 81 is 9. And these are really close to one another. 80 is just a little less than 81. So remember, my estimate right here was, it looks like I was a little off, but it looks like it's about 8.9, like I said. But it's between 8 and 9, and you can use this to kind of roughly estimate your distance. So I would update this to about, 8.9. Now this one is approximately 8.9, but we need to reduce this radical. Reducing radicals means there's a couple of ways to do it. We're going to look for a perfect square factor, or we're going to do a factor tree. I'm going to go ahead and do the factor tree for you. I know that 80 is 8 times 10, and I know that 8 is 2 times 4, and this is 2 times 2, and this one is 2 times 5. I have 1, 2, 3, 4 2's being multiplied together times 5. That means that 80, the square root of 80, is 2 times 2 times 2 times 2 times 5. I can take out this pair, and I can take out this pair. That is 2 times 2 times the square root of 5. I took these pairs, this pair out of the radical, and this pair out of the radical, and I get 4 root 5. A more direct route to take is to realize that 2 times 2 times 2 times 2 is 16. This is the same as 16 times 5. If you can see this directly, it's actually even easier because the square root of 16 is just 4. So separating these out, this is 4 times the square root of 5. You can take out pairs, or you can take out perfect squares. Either way, you get the same answer, of course. These are the exact value for the square root of 80. Same thing. 4 times the square root of 5. It is really close to 9, so our estimate is about 8.9. You can use your card to estimate it, but it's not going to be as close as your estimate using your values. You should be able to do this for BC now, so I'm going to have you find BC. Find the slope of BC, use the unreduced slope to find the distance. Okay? Well, good luck with that. And